Okay, so this is lesson 10, and well, the number really doesn't matter. We are going to be looking at relationship between the angles formed by parallel lines cut by a transversal. So let's cut to the chase, and these are your objectives, whatever you should be able to do after this. Let's start with definitions. Complementary angles are angles whose sum is, well, 90 degrees. Supplementary angles are angles whose sum equals 180 degrees. A right angle measures exactly 90 degrees. A straight angle measures exactly 180 degrees. These are things that you need to keep in mind and need to memorize, okay? These are facts that you should always have available. Okay, an acute angle is an angle that measures, well, it's an angle that measures less than, it's greater than 0, but it's also less than 90. Yeah, but why are you using this for greater and this for less than? It's the same thing, look. If 0 is less than x, x represents all the degree measures between, in other words, okay, let's put it this way. X is between 0 and 90, not including 0 and not including 90. That's basically what it means. All right. An obtuse angle, okay, or as my son said, an obtuse angle. So an obtuse angle is an angle that measures, okay, is greater than 90, but it's less than 180 degrees. Okay, a straight angle has the shape of a straight line. True. So what? True. Okay, and that's it. Let's move on to the next page. All right. So we have a diagram right here, and I'm going to tell you right now to answer all the questions. All right. So interior angles. These are parallel lines. So you need to understand something. The interior of these parallel lines, it's the space between the two parallel lines. Here, this is the interior. Anything here is the interior. And of course, anything outside that is the exterior. Okay? So let's answer the question. The first one says, interior angles. And look at this. If you read it, you will figure it out. Interior angles are angles that are in the interior of the two original lines, which are, and of course, let's see what's up. Interior angles. 3, 4, 5, 6. 3, 4, 5, 6. So angle 3, angle 4, angle 5, and angle 6. Okay, so now exterior angles. Exterior angles are angles that are in the exterior. So that will be 1, 2, 7, and 8. So angle 1, angle 2, angle 7, and angle 8. Next one. Alternate interior. Okay, alternate means one side to the other. One side to the other. That's not really the true definition of alternate, right? Alternate means alternating. Okay, you first, then the next person, then the next person, and then, okay, like a zigzag. So the way to do it is the following. Alternate interior. So they're going to be in the interior of the lines, and it's going to be alternating. So this is one of the interior angles. So to alternate, I'm not going to go here. I'm going to go here. Think of it as a Z. I don't have forget it. Alternate. So this is angle 3 and angle 6. See, alternate. They form like a Z. El zorro. So angle 3 and angle 6, and also angle 4, okay, and angle 5. So how do I write that down? Easy. Angle 3 and 6. So alternate interior. Angle, okay, put parentheses, angle 3 and angle 6. See, pair. The next one will be angle 4 and angle 6. Look, angle 4 right here and angle 6, alternating in the interior. Angle 4 and angle 5, I'm sorry. Okay, angle 4 and angle 5. Okay. Alternate exterior. Well, the same idea applies. Alternate exterior. So let's see. In the exterior we have angle 1. So angle 1 goes with angle 8. Okay? Angle 1 and 8 and also angle 2, which is to the right, with angle 7, which is to the left. So angle 2 and 7. Oh, okay. Same side interior angles are angles that are on the same side, okay, of the transversal, but in the interior of the original lines. Of course, same side interior. So we look at the diagram. This is the interior. So same side would be 3 and 5, 4 and 6. Angle 3 and 5 and angle 4 and 6. That's exactly what it is. Okay? Cool then. Let's move on. So once again, I have the same diagram on the other page. And now we're going to look at what else? Or same side exterior angles are angles on the same side of the transversal but are in the exterior of our lines. In this case, they are, well, 1 and 7. What else? 2 and 8. And that's it. Same side exterior angles. Now vertical angles. What are vertical angles? Vertical angles are angles formed by two intersecting lines. Like for example, let's just take a look at this intersecting line right here. These are the two intersecting lines. That's what you have. So vertical angles will be angle 2 and 3. Okay, they opposite to each other. Therefore, 1 and 4 are also vertical angles. Correct? Okay then. So 1 and 4 are vertical angles, 2 and 3. Angle 1 and 4. Okay, angles 3 and 2. Angles 5 and 8. And angle 6 and 7. Now, what's so peculiar about this? Well, vertical angles are congruent. Congruent means they have the same measure. Like for example, a straight line. Okay, let's give a measure to this one. Let's say this is 130 degrees. In a straight line, it's a straight angle. We have 180 degrees. So if this is 130, this has to be 50. So it could sum to 180 degrees. Same way it goes for this straight line. So if this angle 2 is 50, then angle 4 has to be 130 because it's a straight line. And if this is 130, since this is a straight line, this has to be 50. And therefore, we conclude that these two angles are congruent and these two angles are congruent. And that's why they call them vertical angles, and they say that they are congruent. So let us label which ones are the... Que estúpido. Oh my God, guys, I made a mistake. These are the vertical angles. Let me just write them over here. I made a mistake. Oh my God, thank God I caught it in time. Sorry, these are not. I was looking at this, and if you caught that mistake, thank you for not writing it. So corresponding angles. What are corresponding angles? Corresponding angles are angles in the same relative position. What the hell does that mean? Easy. Let's take a look at these scenarios right here. Let's pretend, okay? Let's pretend that this is not one diagram, but it's two diagrams. So I'm just gonna, the red line will divide the diagrams. So on this diagram right here, I have, look at the diagram. I have angles 1, 2, 3, and 4. In these ones I have 5, 6, 7, and 8. See that? Okay then. So if I was to be on the same relative position as angle 1, look at where angle 1 is. It's on this side, on the upper left of the intersecting lines. So which angle is on the upper left of these intersecting lines? On the upper left. Well, lower left, upper left. See that? So angle 1 corresponds to angle 5. Then if I move down to angle 3, then I gotta move down to angle 7. If I move here to angle 4, then I gotta go to angle 8. If I move here to angle 2, I gotta move up here to angle 6. So those are corresponding angles. So 1 with 5, 3 with 7, and so on and so forth. So that's exactly what I'm going to write here. Angle 1 and 5, angles 3 and 7, angles 4, 4 and 8, and angle 2 and 6. Okay, hopefully you understand that. All right then. So the next are just series of postulates of what I just explained. Look, it says it right there. It says if parallel lines have a transversal, then corresponding angles are congruent. We just said that corresponding angles are congruent. All acute something else. All acute angles in a diagram like this are congruent. So congruent angles will be 2, 3, 6, 7. As well as all the obtuse angles are congruent. Look, 1, 4, 5, 8. Okay. So just read through the postulates and you'll see that they say exactly the same thing as we were just discussing. Okay, cool then. Now the intersection of two planes is a line. Okay, if you try to make two pieces of paper intersect, okay, like this. Oops, let me zoom out. Okay, this is a plane and this is another plane. One plane, two planes. You see that? This is a paper. Okay, so the intersection of two planes is nothing more than a straight line. If I take this, okay, let's say I mark the intersection of these two planes. If I take this from the intersection, look what is left, a straight line. Okay then. Now what else do I need to know? Easy. If there are three planes, right? There are two planes that, whether they parallel or not, but there are two planes right here. See them? Okay, and there is this big plane intersecting both of them. The intersection of this plane with this one is a straight line. Then when it goes to the other plane and intersects it, is another line. Therefore, if two parallel planes are intersected by a third plane, then the lines of intersection are parallel. These are two parallel lines. Just don't ever forget that. Okay. Now we're going to prove that, okay, we're going to prove that alternate exterior angles are congruent. It says given A parallel to B with transversal T. Prove that angle 2 is congruent to angle 7. Okay, I'm supposed to prove that angle 2 is congruent to angle 7. So when you write a proof, it's usually, okay, this is the formal version. When you write a proof, you have to have two columns, one for the statements and one for the reasons. Your first statement will always be the given statement. You see here, it was given to you that A was parallel to B with a transversal of T. So that's the first thing you write. A is parallel to B with transversal T. The reason, given. Then from there you start making your own conjectures and conclusions. So you know that these two lines are intersecting. These two lines are intersecting. So therefore 2 and 3 are vertical angles. And because they're vertical angles, they are congruent. Okay. So then that could be one. Then you know that 3 will be congruent to 7 because all acute angles are congruent, but of course that's not sufficient evidence. You have to say that 3 and 7, okay, are corresponding angles. They correspond to the same relative position. So then, let's start. So 2 is congruent to 3. 2 congruent to 3. Why? Because they're vertical angles. See that? And vertical angles are congruent. Then we said that 3 was congruent to 7 because they are corresponding angles. And that's what we write. 3 is congruent to 7, or angle 7 is congruent to angle 3 because they are corresponding angles and corresponding angles are congruent. Last but not least, okay, I can substitute equals with equals. So 2 is congruent to 3. 7 is also congruent to 3. So if I substitute 3 with 2, right, then this 2 comes here. Therefore, Angle 2 is congruent to angle 7 by the substitution postulate. But of course, could I have used something else? Of course I could have. If A is equal to B and B is equal to C, then A is equal to B. So if angle 2 is congruent to angle 3 and angle 3 is congruent to angle 7, I can automatically say that angle 2 is congruent to angle 7 by the transitive property. But in this case, so remember that there are many ways in which you could actually prove theorem. All right, with this one, I don't think you need any help. Corresponding angles, I'm gonna tell you what they are, but I'm not gonna write them because I don't have the time for this. Corresponding angles. So once again, for corresponding angles, you need to divide your diagram into two equal diagrams. So notice that here you have 1, 2, 3, 4. Okay? 1, 2, 3, 4. Here you have 5, 6, 7, 8. So 1 belongs to 5, 2 corresponds to 6, 3 corresponds to 7, and 4 corresponds to 8. So when you write them down, okay, you write, okay, angle 1 and 5, because 1 corresponds to 5. Then here you write angle 2, okay, corresponds to 6. Angle 3 corresponds to 7. Angle 4 corresponds to 8. And that's it. Then alternate interior, well, let's go to the interior and we go 3 and 5, 2 and 8. Alternate exterior, sure, exterior. So 4 with 6 and 1 with 7. Same side interior or consecutive angles? Ah, consecutive interior. All right. Same side interior. So these two angles are same side interior. And as we just realized, they are also called consecutive interior. Not a problem. 3 and 8. Guess what? 2 and 5 are also on the same side. Yes. And same side exterior, well, remember, this is what determines the interior from the exterior. So same side exterior will be 1 and 6 on the same side. 4 and 7. Vertical angles. Vertical angles. Remember, vertical angles are formed by two intersecting lines. So, and they are opposite to each other. So 1 is vertical to 3. 4 is the vertical angle of 2. They have the same measure. Same way, 5 is to 7 and 8 is vertical to 6, or 6 is vertical to 8. And that's it. Last but not least, a linear pair. What's a linear pair? A linear pair, well, if you have a straight angle that measures 180 and you decide to like divide it like this or like this, it really doesn't matter, then this angle right here with this one forms a linear pair. Also, this angle right here with this one forms a linear pair. And this one with this one forms a linear pair. In other words, they have to share the same vertex. This is the vertex of this angle right here and the vertex of this angle right here. And since this is a straight line, it forms 180 degrees. So a linear pair forms 180 degrees. So let's see what are the linear pairs right here. 1 and 2, 2 and 3, 3 and 4. 8 and 5, 7 and 6, 6 and 5, 7 and 8. Bada bing, bada boom, and that's it. All right, let's move to the hardcore. Based on the diagram, okay, which statement is true? Well, A parallel to B. A parallel to B. If they were parallel, remember this is 60 degrees. So since this is a linear pair, then this angle right here is 120. Now this is 110. These are corresponding angles. See, this is to the left, upper left, and this is to the upper left. So if they're congruent, they should have the same measure. 110 is not congruent to 120, so unfortunately they're not parallel, because that's one of the conditions, that corresponding angles must be congruent. A is congruent to C. Line A congruent to line C. I don't think so. Look, different measures. Okay. B to C. B to C. No, not the same measure. Okay, what about DE? Line D and line E. Of course, I mean, they look like that, and That's the only choice. But why? Easy. If there are certain conditions that have to be met, at least a minimum, for two lines to be parallel. Either alternate interior angles are congruent, either corresponding angles are congruent, either alternate exterior angles are congruent, okay? And so on and so forth. All of the things that we just saw before. So, this is 120, and this is 120. This is an exterior angle, and this is an exterior angle. So, these are alternate exterior angles. If you didn't want to use this part, easy. This is a straight line, so if this is 120, this must be 60. Now we're not talking about the exterior, now we're talking about alternate interior angles. So you see, there's so many ways in which you could do this. So it says, explain your reasoning. What makes you think that you are correct? Well, because of alternate exterior angles or alternate interior angles, you choose and you make the best decision. Alright, so we have this diagram. And it says that angle 1 is 7x. Then angle 2 is 5x plus 30. Alright, these lines are parallel when x equals, well, first of all, 1 and 2. What are these? Alternate interior angles. And what do I know about alternate interior angles? That they are congruent. Meaning that they have the same measure. Oh, wait. So you're saying that angle 1 is supposed to have the same measure as angle 2. That's exactly what I'm saying. Okay, so then let's use the substitution postulate. So what is angle 1? 7x equals, and then what is angle 2? 5x plus 30. Okay, and now I just solve for x because that's what they want. For what value of x will these two lines be parallel? Well, let's see. I'm going to subtract 5x from both sides, or just take this 5x and subtract it over here. So I end up with 2x equals 30. Now, I'm going to divide by 2, and x equals 15. So you got your answer for that value of x. Alright, so we have the diagram below, and we have parallel lines cut by a transversal. What value of x would make lines N and M parallel? Well, let's see. What value of x? X. In order for me to prove that these lines are parallel, I could prove that corresponding angles are congruent. So I would need this value right here. Oh, okay. So what do I know? Well, I know that this is 30. And this must be vertical with this one. So if they're vertical angles, then this one should also be 30. Okay. What else do I know? That N is a straight line. So that means that it measures 180 degrees. So if this is 30 and this is 80, that's 110. So what will make this angle? Okay, this angle will turn into 70 because that's 180. And because they are corresponding angles, then x must be 70 as well. Therefore, you got your right answer. Now, what concepts did you utilize to arrive to your conclusion? Was it vertical angles or the definition of a straight angle? Tell me. So yes, I utilized the concept of vertical angles. Then I proceeded to find the missing angle on line N. And then I used the concept of corresponding angles. Okay, then I use the concept of corresponding angles, which are congruent. Therefore, okay, thus finding the value of x, which is 70 degrees. Alright, so you write all that down over here. You have enough space. Now let me move on to the next one. Okay, as shown in the diagram below. So angle 1 is 4x plus 14. So this is 4x plus 14. Angle 2 is 8x. Wow. 8x plus 10. Okay then. So, question. Lines M and N are parallel when x equals. Well, I gotta figure out what the x is. Now these are alternate interior angles, are they? No, they're not. If they were alternate interior, we will have this angle and this angle. Okay, so then how do I know this? What do I do? Oh, I remember. Angle 7 is 4x plus 14. Therefore, this angle is also 4x plus 14. Right? Okay. Now, how does that help me? Oh, now look at P. It's a straight line. And this right here is an angle of a straight line, and this is the other. This is a linear pair. And we know that linear pairs, okay, are two or more angles that are on a straight line and share the same vertex. So this is an obtuse angle and this is an acute. What do we know about that? They add up, they're supplementary. Oh, right, supplementary angles. So they add up to 180 degrees. That's exactly what's going on. So then I'm gonna use that to set up my equation to find the value of x. So, oh, by the way, so basically angle 7 plus angle 2 equals 180. Yes. So I have 4x plus 14, sorry, let's put that in parentheses, plus, okay, 8x plus 10, okay, equaling 180 degrees. Yes. All right. So now that it's set up, everything is just child's play, or everything is just simple mathematics. So let us solve for x. So let me add the like terms. So I get 12x, okay, plus 24 equals 180. Now, I'm going to subtract 24 from both sides. So that's 156. So you get 12x equals 156. And now I am just going to divide by 12, okay? And x equals, well, you tell me. Alright, so you figure it out. I'm not sure if that's what it is. Alright, so that's what x is, and now let's move on to the next problem. Remember, you gotta answer this. What is your strategy? What are you going to use? Definition relating to parallel lines, cut by transversal? If so, which definition proves the most useful? Okay. Right now, I used alternate interior angles, and then I used the definition of linear pair or supplementary angles if you want to. All right, here. So we have these two angles. They want to know what value of x proves these two lines parallel. Well, these are alternate interior angles. And since they are alternate interior, we know that they're congruent. And if they're congruent, then I just have to set them equal to each other. So 6x plus 42, and look, I always group them in parentheses, okay, equals 18x minus 12. Alright, so let's see, there's no like terms here. I do have variables on both sides, so I'm going to get rid of the lesser one, so I'm going to subtract 6x from both sides. Okay, and now I'm going to add 12 to both sides. Okay, and now all I have to do is divide by 12. So x equals 4.5. And I found my answer. Okay, what definitions did I use? Definition of alternate interior angles. Alrighty. Number 6. In the diagram below of quadrilateral ABCD, alright, and I'm not going to read all this, I'm just going to let you know what's going on. They want to know if AB is parallel to DC. They want to know if AB is parallel to DC. Alright. So out of all the things that I could use, okay, I'm gonna first study what I need. Okay, if I can prove that this angle is congruent to this angle, okay. Oh no. Let me see. Let us just extend the lines because I'm getting confused right now, and I don't know what. Okay, let me extend this line because you know that we can always do this. Okay, now that's better. Now I know where my transversal is. This is my transversal. I was confused. So now I know which one is the interior. This is the interior. Okay, this is part of the interior, but it doesn't go all the way here. But this one right here is part of the parallel line, and it forms the angle with the transversal. This one was not forming the angle with the, it was doing it with the transversal, but not with the parallel line, or the line, whatever, if it's parallel. Now, this angle, if I was to prove that these two lines are parallel, this angle has to be congruent to this one right here. Okay, look, the line and the transversal. Okay then, but then what do? I need to figure out what this is. Oh my God, look at this. This is one triangle and this is another triangle. The angles in a triangle add up to 180 degrees, correct? Okay, so I got two angles right here. So I could just add them up and subtract them from 180 and I'll get this angle, correct? Okay, so that's exactly what I'm gonna do. So 93 plus 43 is 136. 136 subtracted from 180 is 44. So that's what I get. Now, if I can prove that this angle is also 44, then I would have proven that the lines are parallel. So let me get to work on this. So I know that I have three angles, unknown angles, okay, so far, and that they add up to 180, so that's exactly what I'm gonna do. That's exactly what I'm gonna write. So I have, the first one is gonna be x plus 19, okay, plus 2x plus 6, okay, plus 3x plus 5, okay, equals 180 degrees. Let's see if it works. So let me add the like terms. So since everything is an addition, I don't have to change the signs of anything. So x plus 2x is 3x, plus 3x is 6x. 19 plus 6 is 25. 25 plus 5 is 30. And that equals 180 degrees. I'm going to subtract 30 from both sides, and I get 150. And now I am going to divide by 6. And x becomes 25. Okay, now I have not proven anything yet. All I did was found that x was 25. Now I am going to take this value of x and I'm going to put it in here. Okay, so let's see, x is 25. So 25 plus 19 equals 44. 25 plus 19 is 44. So this angle here is 44. And alternate interior angles are supposed to be congruent. Therefore, these lines are parallel. Got it? Awesome. This question is going to be on the test OD. And if you cannot answer, of course, I might change the numbers. All right. Here. Come on, kakar. Come on, kakar. All right. In the diagram below, these two lines are parallel. They're telling me that. Now, QR is perpendicular to ST. QR is perpendicular to ST, so it forms a 90-degree angle. Okay, they want to know something. If the measure of angle 1 is 63, so this measure of angle 1 is 63, they want to know the measure of angle 2. Well, let me use my skills. So this is 63. This is a transversal. So, if this is 63, these are alternate interior angles. Therefore, this is also 63. Now look at this. I got 63 and I also have a 90-degree angle right here. So I have 153 degrees here. Okay, so, well, if you have 153 degrees and you know how many degrees in a triangle, right, 180. So take 153 from 180 and you get your answer. You gangster bucker. So yes, measure of angle 2 equals 27 degrees. Okay? And remember, if you want to justify your response, you have to state that, okay, angle 1 and angle RTQ are alternate interior angles. Therefore, they have to be congruent. Then, since I already have the measure of angle R, which is 90, then I add this and I have 153 degrees. Not only that, these QRT form a triangle, and the sum of the degree measure of each angle in a triangle, sorry, the sum of the angles in a triangle add up to 180 degrees. So then you take away 153 from 180. Cierra la puerta. And that's it. That's the end of your lesson. So what relationship between two lines, okay, what are the relationship between two lines? Check all that applies. Well, the lines could be parallel, they could intersect, they could be skew, they could be coplanar, they could be perpendicular, yeah. Okay, wow. What else? What are the relationship between two planes? Check all that apply. The planes could be parallel, they could intersect. Two planes can never be skew. Skew means that when one goes one way and the other one goes the other way, like that. Or let me see if I can do this. One on top of the other that never intersect. Non-parallel? No, they cannot. Coplanar. Two planes cannot be coplanar. You cannot have a plane inside another plane because they extend infinitely. Can they be perpendicular? Hell yeah. Okay. The intersection of two planes is a straight line. Or you know what? Let's just say a line. Because the path traced by the intersection forms what? Yeah. A straight line. Okay. Last but not least, the intersection of two parallel lines intersected by a third plane forms a pair of parallel lines. Okay? As simple as that. And then you have your little, okay, key facts that you have to study and memorize. We already went through all of them. Now it's your responsibility to study all this. So we have vertical angles, okay, intersecting lines opposite to each other. Then we have that if C is a point in the interior, okay, where is C? Here in the interior, okay, of AOB, then AOC and BOC form AOB. This angle and this angle form AOB. Yeah, sure, whatever. Let me see if I can zoom in. It's still, even if I show it to you like that, the printer is not that great. All right, and the next one. Oh, and why this angle and this angle form this big angle? Because of the addition postulate. Well, it says it right there in your paper. Okay. Here, two angles that form a linear pair are supplementary. We already did that. This is a linear pair. Look, straight angle, and it gets divided into two different angles, but with the same common vertex. Okay. Now, another one. It says, given a sequence of n consecutive adjacent angles, these are consecutive adjacent angles, okay, whose interior are all disjoint such that the angle formed by the first, okay, n minus 1 angles and the last angle are a linear pair. Wait, so if all these angles form a linear pair, and we already discussed what a linear pair is, are angles on a straight line. So that means that the sum of all these consecutive angles has to be 180 degrees. Okay? So what could be, when we conduct a proof, what could be a good reason? Consecutive adjacent angles, adjacent because they all share the same vertex, okay, on a straight line, which is 180, sum up to 180. And last but not least, okay, angles at a point sum to 360 degrees. All right, the sum of the measures of all angles formed by 3 or more rays with the same vertex and whose interior do not overlap is 360 degrees. Here, the sum of the three angle measures of any triangle is 180. In other words, the sum of the angles in a triangle is 180. All right. When one angle of a triangle is a right angle, the sum of the measure of the other two angles is 90. Duh. If this is 90, and since a triangle has 180, then this and this has to be 90 when you add them up, because you already have one being 90. All right. Here, this exterior angle of a triangle is equal to the sum of the two non-adjacent angles. In other words, the sum of the two opposite ones. Okay, adjacent means that you share the same vertex. So the sum, the measure of an exterior angle is equal to the sum of the two non-adjacent angles. All right. What else? In an isosceles triangle, the base angles are congruent, and opposite to the congruent angles are congruent sides. Okay. In an equilateral triangle, all angles are the same. And this is nothing more than a repetition of what we just saw. Okay. You could read it yourself. I'm not gonna read it. Okay, and that's the end of this lesson. All right, see you. Bye-bye. I think this was the beginning of the other lesson. Whatever. I caught you.